Hi, everyone. So I'm just following Fernando. So you already heard about the CAMI portal. He gave a bit background of CAMI. And we're now currently in the process of preparing new challenges. So after CAMI challenges, always before the next CAMI challenge somehow. And I wanted to use this opportunity to get already some inputs on how to define and shape things in that. Is this on? So, oh. Okay, maybe I'll just use this. All right, so you've seen this slide. Just as a brief recap, so in CAMI, we're creating benchmark data sets. We have a known ground truth, so we have high quality genomes in which we create metagenome microbiome, microbial community abundance profiles, and then we can simulate data, currently shotgun metagenome data, but we do want to expand to transcriptomics, and it will be, we already have a part of that in a simulation tool, like you can see that in other branches of the CAMI-Sim software that is publicly available if you want to play with that. And so then define benchmarking challenges based on this data. And so from the clinical domain, we have done a clinical pathogen detection challenge. So you get a real sample from the clinic. There's been a diagnosed pathogen infection, and people are asked to identify this particular pathogen, which is an etiological agent in the disease. And then these categories we just heard about, so profiling, then the assembly, and then genome or taxon binning, which differ. In taxon binning, you also need to assign the taxonomic label correctly. And these are being evaluated in the CAMI contest, so people can participate at all levels, contributing data, creating challenge data sets, submitting tools, contributing to thoughts about metrics, evaluations. So all input is welcome. So currently, the CAMI3 challenge data sets, so one key point is that they will include both public and unpublished genomes. So the unpublished genomes are important if you're for many reference-based tools like profilers, and taxonomic binning tools. So you do want to work with data that's not part of the reference database, because that's harder to classify correctly than if it's exactly the same genome is already included there. We cover a range of different samplings, like to reflect real experiments that are commonly performed, both long and short read data with the latest technologies. And so in terms of environments, so there are so-called toy data sets released before a challenge, so people can familiarize with the data and formats and everything. And so we do have human toy data sets, which also people have found useful. But now we want to do more from the human domain. So different human body size again, but also clinical studies, longitudinal data, microbiomes reflective of different patients. And probably also some plant and soil-associated communities. So we heard yesterday from Chris Quincy, these are super complex sometimes. And maybe also an ancient DNA challenge, so there's some interest in that. And another novelty will be the meta-T generation. All of this will need some time, so the challenges will come now consecutively, not all at the same time. So the timeline for the challenges, we're currently having some workshops, gathering inputs at ISMB, but also in Ascona. There was a meeting with benchmarkers, a benchmarking meeting with experts on benchmarking and also on transcriptomics. And we're working on a first toy data set that will be released to the CAMI portal very soon, hopefully sometimes in early fall. And then we could start one of the new challenges. There will be a deadline for assembly first, and then subsequently for binning, because we will release gold standard perfect assemblies, ground truth assemblies for binners to work on. And then we will be doing some more challenges afterwards. And we have to see what we can present at which meeting and for people to provide inputs and discuss. And one thing I was hoping to get your inputs in already is some of those metrics. So obviously metrics are really important. They're reflective of different things. And one thing people say, it's not sensible to just have one metric representing everything, because there's so many facets to performance and applications. But for example, in the portal, there's different ways to rank things, and there's also this aggregated summary, which is based for the different categories on these things that are shown here. And in some cases, we already got expert input. For example, for assembly, we have this was adapted, we have a measure of how well assemblies actually recover individual strains. So this requires like little mismatches, good coverage of the strain, and this is represented in this F1 score. there's a new metric instead of NA50, which gives you assembly contiguity, which is called the area under the NGA curve. So this is like a more comprehensive measurement of that. There's a new measure for sequence identities, which aggregates information on mismatches, indels, and ends. And then what's been widely used is a genome fraction, like how much of a particular genome has been recovered. And all of these are also available in the portal if you want to use them for now. There's for genome binning, we have like this bin or genome specific perspective on average completeness and purity of bins, sample specific metrics. So the adjusted RAND index gives you a quality of the binning compared to the ground truth clustering on the percentage of base pairs that are assigned. And then just what's also very often used is a number of mags recovered with high quality. So these different quality levels that you saw in talks. And then for taxonomic binning, there's also, now this is per rank. And also for the bins versus ground truth bins versus predicted bins, there's average completeness and purity, and that's summarized in an F1 score. And as a sample view metric, the accuracy in base pairs of how much was assigned correctly. And for taxonomic profiling, we have metrics, representatives, how well do these profilers recover the identities of the taxa sample with completeness, purity, and the F1 score, and then metrics that represents how good are the abundance predictions. So this is the L1 norm error, Bray-Curtis distance, and across all ranks, the weighted unifrac. And then there's a metric representing the evenness or diversity of the community, how well was that predicted using the Shannon equitableity. So I hope there's some developers here, and maybe they, if you want, you can provide some inputs or thoughts. And yeah, Fernando already showed all the slides with all the people that are contributing. I have to update my numbers. This is just CAMI 2, I think. Yeah, and so we really are happy to hear from you. If you have methods you want to assess, you can go to the portal, get in touch with us, new challenges to suggest. We are always happy, also very happy to get unpublished data. Yeah, and hear from you. So thank you.
Yeah, thank you. Can you just start?
Nice talk. Here. So I have a quick question because it seems AIs are everywhere, right? So I'm wondering, do we have any benchmark training data rather than the evaluation data for fair comparison for the ones that design the large language model, the foundation model?
Yeah, so some of these tools actually are language model based. Those tools can participate just as well. I think we do see that, like we've had some talks, people training genomic language models, trying to predict taxonomic profiles or marks. And they, of course, they're also very welcome and can use those data sets, and they do.
Yeah, sure. I mean, although they try to predict on a CAMI data set, but they might contain the genomes in the CAMI.
Yes, that's correct. Yes.
Yeah, so that will might lead to the data leakage problem, right?
Yes, absolutely.
Yeah, yeah.
That's exactly why we need those unpublished genomes. So that problem is the same for those models as well as for reference-based profilers and binners. And then that's also why you might, if you go to the portal and you now see results for tools that have been run after the CAMI challenge, they could be on top because they've used it in the training data, maybe they've optimized on the data, whatever. And that's why we need the blind benchmarking challenges with new data, not in reference databases. Yes. Mm-hmm.
Thanks. Really nice. So, like, if you were sequencing a real human, so say microbiome, you obviously have some human sequence in there. Is that something you're thinking about spiking in for your evaluations also?
Yes, we have that in the clinical pathogen detection challenge, but we replaced the real patient data, which we are not allowed with some public human data. Mm-hmm.
And then there's also the kind of reagent microbiome.
Yes.
Bacterial signal coming in. Is that something you're thinking about as well?
Yes, definitely. I mean, it plays the biggest role in these low biomass environments. Yes. I think so. Also, probably for this case, so we haven't included this, I think, the kitome or into one of the simulations yet. But thank you for the suggestions. Definitely something to think about for that question. Mm-hmm.
Yeah, I found that probably.
Mm-hmm.
Okay, last quick question.
I really appreciate the problem of finding unpublished data sets that mustn't be very easy. But I was wondering if I seem to remember there's a few like associated and water data set and then some data set I saw from various characteristics. And I was wondering if we plan to go somewhere like I think of a lot of colleagues who work like in Antarctica and like remote places where microbiomes are like extremely undercharacterized, and I'm always wondering how representative these benchmarks are for these people to make decisions regarding their methodological choices. So I was just wondering your thoughts about how you would again appreciating the complexity of finding unpublished data set, but to expand on those microbiomes that may be undercharacterized in benchmarks.
Yeah, absolutely. That's an interesting suggestion. So if people are interested to work with us, like they're very welcome to come. Like, we can start from taxonomic abundance profiles. We would need some data, of course, like that we could work with some genomes. But if people are interested and really want to use this framework, like they can approach us. We also, by the way, have a position focusing on data creation and expanding the kind of simulation framework. So if anybody's interested, so really welcome to get in touch. Thank you. So if you know someone, we're happy to discuss and see what we could do.
Okay, Alice, thanks again.
Right, thank you.